All right, we're going to look at finding some area of triangles here. Now, most of you know a formula for the area of a triangle. You can say 1/2 base times height, but it's kind of unrealistic to use that formula, even though that's probably the most common one. But what makes it kind of unrealistic is most of the time when you have a triangle, unless it's a right triangle, chances are you're probably not going to have the height given to you. Okay, and so we're going to look at some trig formulas here that can find the area where you don't really have to know what the height is. Okay, you just have to know just a few things about it, and then you can find the area. And the formulas that we do here, and when we calculate the area, this is also in your program. Your program calculates the area of your triangle too. Okay, now, so we're going to look at 3 different formulas here for 3 different cases. All right, let's start off. I'm going to do this one first, the side angle side case. Okay, and the formulas are on the board there to your left, and they're on your reference sheet here too. So this one, and then Hero's formulas right here. Okay, yes. Okay. And plus they're on the board. All right. Now, so for the side angle side case, and for some reason the trig formulas use K to represent the area. Okay, so why do they use K to represent area of a triangle? I have no idea. Okay. Every book I've ever seen uses K for the area of a triangle in trig, so I don't know why. All right, but here's the formula. I'm going to just give you one of them. 1/2 times AB times the sine of C. Okay. Now, there are really 3 versions of the formula depending on what you're given. But one of the things that you do when you look at the formula is you don't really look at the details, you just look at the big picture. Okay? Side angle side, you're given 2 sides and the angle between them, right? Okay? Now, what is A and B going to have to represent? The 2 sides. And then big C right here would represent the angle. So which side is A and which side is B and which angle is C doesn't matter. You just use this same formula for every triangle. You don't really have to use all 3 formulas. So you just put the 2 sides in right here and the given angle in right here, and you just calculate it. Now, and notice, what about the order though? Would the order matter? Because you're multiplying all that out, it doesn't matter. All right, let's look at an example, okay? So I'm going to do one kind of similar, and by the way, this is in your textbook. The textbook does give you all 3 formulas. I'm trying to find where they're at. I'll write the page down so you can see all 3 of them. All right, it's on page 315, okay? If you want to see all 3 formulas, but one is sufficient. All right, so I'm not even going to label the triangle when I draw them, okay, because I really don't need to know which is angle A or B or C. I just need to understand the general formula. Okay, so now let's put these in our formula. So notice this is side angle side. All right, so the 2 sides we're going to plug in right here, and then the angle we're just going to plug in right there. And so, by the way, where the connection to what we're doing right now to this is that these formulas today are going to be derived from the laws of sine or laws of cosine. That's where they come from. Okay? And even though this is a side angle side, this is actually derived from laws of sine. All right. Now, let's put them in here. So let's see, we'll get 1/2 times. All right. Now, which side do y'all want to put first? All right, 4.7. Okay, times 12.4 times sine 47 degrees. Okay, and so all we have to do is just grab our calculator, throw all that in. Now I would probably, instead of 1/2, I'll just push like a 0.5 instead. Okay, let's look for my scientific calculator. This is the second time this has happened. All right, so let me throw it in. I'm assuming here that we're in degrees. All right, so I'm going to do 0.5. All right, times 4.7 times 12.4 times sine 47. Okay, so now we're going to go to the 10th place, about 21.3, and I'm going to put square units here because this is area. Okay, area is measured in square units. All right, did y'all follow that okay? All right. Did you understand about the part about the formula is just which formula you use really doesn't matter because you're only going to have two sides and an angle. No. That would be fun though. Okay. Work backwards. All right. Now that's for side angle side. We got two more. Okay. And the next one's probably the only one that's going to be the least bit challenged. Okay. Right. Right, for all of them. Okay. So notice I'm not going to label my triangles with A's, B's, and C's. I'm just going to look at the pattern of the formula. And so the pattern of the formula is 1/2 times one side times the other times the sine of the angle given. Okay. Now, the other one, of course, this one has three formulas that go with it too. Okay, and it's over there on the board too. Now, this is for angle side or angle side angle, which really are the same case. Because if you're given two angles, you can find the third angle. And so that's why really those two are really the same. Now, here's one of those three formulas that go with it. So it's 1/2 times a squared times sine of b times sine of c over sine of a. Yes. Yes. Now, again, look at the pattern. How many sides are given in either one of these cases? One. So obviously that side has to go right here. Okay, so that's pretty obvious. Now, what's not obvious is you're taking the sine of all three of the angles. Now, you're only given two, but you could find the third. Okay, but you have to figure out, well, which two go in the denominator? Exactly. Do you kind of understand what he was saying there? All right. The side that's given here is the A side. So the A angle goes on the bottom. So whatever side is given, the angle that's opposite goes in the denominator. Right. Okay. So there again, you don't really have to use all three formulas, just use the pattern. 1/2 times the side squared, and then times the sine of all three angles. Right. Right, exactly. Okay. So if the B side was given, then sine of B would go on the bottom. Okay. And the A would go on top. Okay. There again, you're going to see me when I do my triangles, I don't even label them. Right. So whichever side is given, the angle opposite of that goes in the denominator. Okay, let's look at an example. All right. Okay, I'm doing really basically, this is on the bottom of page 315. And this is also, all three formulas are on page 315 here too. Okay, so this triangle gives you 14.8 degrees and 34.4 degrees on those two bottom angles. And this side's 13.9. Now really that's angle side. It really doesn't matter if it's angle side or angle side angle. Okay, so before we start doing in our formula, something that we need to do there. Yeah, find the third angle. Okay, so 14.8 plus 34.4, and then we'll subtract that from 180. Ooh, I messed that up. Okay, so we got this angle's 130.8 degrees. Okay. All right, now, so let's plug into the formula now. So here we go. 1/2 times, now there's only one side there, right? So what's going to go in there? 13.9, okay, squared. Now, we got the sine of the three angles, 2 of them in the numerator, 1 in the denominator, okay? So the one in the denominator is the one that's opposite of the given side. So always do the denominator one first because the other two aren't going to matter. So it's going to be sine of which angle? 34.4, okay? And then the other two angles, their order really doesn't matter because they're multiplying at the top. So see, I'm going to say sine of 14.8 times sine of 130.8. Okay, and now I'm just going to throw all this in the calculator, okay, just the way it looks. I'm going to do, let's see, 0.5, okay, instead of doing a half, times 13.9 squared. Oh, and by the way, I didn't mention this on the first one. You have to show this for me, okay? Because you have the program, you have to show this for me, unless you want to not use the program, okay? You don't. If you give up your program on your calculator, you don't have to show it for me. Anybody want to give it up? Didn't think so. All right. All right. So I got times sine of 14.8 times sine of 130.8. Okay, and now be sure you're closing your parentheses there. If you don't close those parentheses, that could really mess that up. All right, divided by sine of 34.4. Okay, so that's about 33.1. And we'll say this is, again, it's in square units. Okay. All right, so talk to me here. Do we need to see another example of this formula? Yeah. Okay. All right. Let me do. This was what angle side. Let's do an angle side angle. Okay. I'm just gonna make up some numbers. All right. Let's say this one's 40. Yeah. And let's call this one 8. This one's gonna be angle side angle. Okay. So let's say this side down here is 12. Okay. So first thing I want to do here would be to find the third angle. So that's 120. So this angle would be 60, right? Okay. Now, let me copy down my formula. We'll figure out how to plug in 1/2 a squared times sine b times sine c over sine a. So 1/2, only one side there, 12, okay? All right, but we got to figure out, all right, which angle is going to go on the bottom down there, right? The 60, because it was opposite of the side that's given, okay? So this and this, it's kind of like, you know how we do like laws of sine? How the side opposite, that's where it comes from, is laws of sine. So, I mean, that's why it happens that way. It's no coincidence, all right? So sine 60 goes on the bottom, and then the sine of the other two angles goes on the top, and the order doesn't matter on those two. Okay, now, let's just throw all that in. So I'm going to do 0.5 times 12 squared times sine 80 times sine of 40 divided by sine of 60. All right, so let's see, our area here is about 52.6 square units. All right, and really that's the most confusing effect right there. Side and the angle across from it, okay? All right, the next one in, the last one here we're going to do is for side, side, side. And I don't have on I don't believe I have on the reference sheet that it's for side, side, side. It's usually the most useful one, because normally what you know on a triangle is the three sides, okay? Now, this, right? Now, in this formula, you're going to have a variable here that's going to be kind of confusing as to what it is, and it's the variable s. But s times s minus a times s minus b times s minus c. So you can probably guess, since we're doing c, are the sides of the triangle. Okay, so what's s? Right? Semi-perimeter. Okay, how'd you know that? Board over there. Yeah. Okay. So what's the semi-perimeter though? Okay, half of the perimeter. Mm-hmm. All right, what's the perimeter? Is half of perimeter. I mean, all the sides and then divide by. All right. So let's look at an example of this one. Let me tell you what the formula is at too. This one's in the law of cosine. It's on page 330. If you don't believe me, I could be like making up formulas and y'all would never know. Okay. Now let's do their triangle here on example 4. That's on this page. Okay, you're given, and notice I don't even like triangles because I want to stay away from the A's, B's, and C's here. I just want to use general patterns on the formulas. Okay. In the triangle, or in the formula, we want to find the semi. Okay. So let's see. We find my, that's 83, 95. All right, that'll give me the perimeter. Now I don't want to divide it by 2 on my calculator here, right? Divide 95 by 2. 1.5. Okay, so my perimeter is 250. All right, my semi-perimeter is 125. Okay, now I shortcut this formula a little bit. Same S. Yeah, they're all little. I'm sorry. Instead of writing 125 minus one of the, so y'all just want to start. And then 125 minus. Okay, now, so this is what you program, and it tells you the area in the program. Times 42 times 30. Centimeters squared, or you can put